Okay, getting rolling here. A live presentation. Hi, my name's Jorn. I'm part of the solution engineering team at a company called NeuVector, and we thank you for joining us today. I got a little bit of housekeeping I'd like to get to, but I want to give a moment to, well, let our three hosts, our presenters, introduce themselves. I'll take it from the top on down. Kevin, why don't you tell the audience who you are, a little bit of your background, please.
Thanks, Jordan. Hi, everybody. My name is Kevin Ng. I'm a solutions architect at Mirantis. Bit of background about myself. Last decade or so, I've been working in multiple different areas, in both as a practitioner and as consultant. Ranging from dev to test, even to release engineering, and now looking at cloud platform and cloud native technologies. So, I'm very happy to join y'all today.
Thanks, Paul. You're next up, man.
Sure. Good afternoon or good morning to folks. I'm Paul Smith. I'm a solutions architect for Sonatype. A little bit of background about myself. Started off years ago as a developer, primarily with C and C++. Then moved into the area of middleware and integration. Then moved into the testing space and then into security, looking at layer 7 traffic. And now today, how we actually create software bill of materials and automate the supply chain across organizations. Good to be with everyone today.
All righty. And Glenn, there's Glenn. Hi, Glenn.
Hey, hi, everyone. Thanks for joining us. I'm Glenn Kosaka. I run product management for NeuVector. We are now part of SUSE, and happy to be part of the SUSE Rancher team. And I'm running the product security function there. Was part of NeuVector in the early days when we launched the company, and Docker containers were the big thing. And as you know, everybody's moved to Kubernetes, so it's been really fun to follow the evolution of the industry and be involved with a lot of this great cloud native technology. So I'm looking forward to hearing from our counterparts at Sonatype and Mirantis today and seeing the entire pipeline security story come together.
Absolutely. Thanks, folks. I also want to give a big shout out to both Uday and Young for actually pulling this together. Lots of things happen behind the scenes just to get a webinar running. From a housekeeping standpoint, there's a Q&A section here in Zoom. Drop those pointed questions in there throughout our broadcast. I'm going to be try to be mindful to keep an eye on those Q&A questions. Our presenters can sometimes see them and sometimes cannot, so we'll try to get to them as they are coming in. Also, this is being recorded. You probably had a robotic lady tell you that it's being recorded. We will publish this recording shortly after it is done. We'll edit it up, get it posted, might be today or tomorrow. Speaking of this week, also, as a thank you for all of you who are attending live right now, we'll be sending out gift cards, likely from Starbucks. We kind of moved over to Starbucks because it made it a little bit easier to do something globally. Your DoorDash, Grubhub, it's kind of hard to make an international answer for that. And well, I'd like to just thank you for joining us. There'll be a quiz at the end. No, I'm just kidding. There'll be a quiz on the inside of your own head. Be mindful as we kind of go through that application lifecycle on top of all the infrastructure and security. Watch for things along that supply chain, that bill of materials. You hear that come up quite a bit throughout this presentation. And ask yourself, hey, how does this apply to the organization that I work with? And maybe even some of those swim lanes, like who might care about this part here? Is it completely dev? As things are shifting left, does that become an operations part? Are we thinking about actual security and compliance in the right part? So there are three presenters, but these stories all actually tie together. And so without any more ado from me, I'm going to actually hand the reins over to Paul. Paul, the floor is yours, my good friend. Thank you.
Thanks, Jordan. Let me just share my screen real quick and then we'll get started here.
We have you, sir.
All right. So good afternoon, good morning, everyone. Again, Sonatype, we're really focused on full spectrum software supply chain management. If you've heard of Sonatype before in the past, you most likely have dealt with open source software and our Nexus repository. That's not the subject for today. What I'm going to be focusing on really is our Nexus lifecycle capability to continuously identify risk, enforce policy, and remediate those vulnerabilities across the entire SDLC. And I'm going to then focus on the integration we have with a fairly new addition to our portfolio, which is Nexus Container. The ability to secure and protect containers from development all the way through to runtime. Again, I'm going to start on the very shift left side, looking at development and application security, and how we're bringing that container information and data into Nexus Lifecycle. Again, our control plane for software bill of materials and supply chain management. So, kind of very simple anatomy of an application here. It can get way more complicated, but we understand we have the application. With that application, we've got our custom code and we've got our open source components and artifacts. Again, Sonatype actually grew its wings, focusing on open source software and identifying vulnerabilities in that open source. As you guys can realize, there's about 85% of applications built today are utilizing open source. You might be familiar with some years back a big issue with Equifax having a breach. And that was due to an open source struts package. And they're now a client of ours, and they're interested in this story that I'm going to present to you today. So, there was an executive order here, I think a few months ago. I want to say it was in May, where the White House put out an order about all software delivered to government would be required to have a software bill of materials. And why is that important, right? So it's important just the way that we build automobiles, right? We've got engines and chassis and bodies and airbags, right? So when you see an airbag recall, that auto manufacturer, they know exactly what vehicles, what VIN numbers those airbags were distributed in. They also know if those airbags are currently on the assembly line at any point in time. And that's what we're doing with Nexus Lifecycle. So again, we started with software composition analysis on open source, where we can generate a software bill of materials for your application. And now with the integration to Nexus Container, we can also generate that software bill of materials for your base image and your container. In addition, we also can scan infrastructure as code. And so what we end up with is really a full spectrum software bill of materials that works its way through the SDLC, and each stop along the SDLC, we may actually have a different software bill of materials. And this is exactly what I'm talking about, right? Is that bill of materials, it changes, right? As we move from our source to builds, and we're fixing, and we're iterating to our release, to our operations. And again, this is exactly how manufacturers, for cars, airplanes, anything, they understand if they have an issue, if there's a vulnerability, they know exactly where those manufactured items are and how to make the necessary adjustments for those defects or vulnerabilities. And before I get into a quick demonstration, I thought just to give you a background on what's important to Sonatype and kind of how the Nexus lifecycle control plane works, right? So we perform scans. I'm going to show you a scan of open source application, a scan of a base image, scan of some infrastructure as code. When we commit those scans, that then ships to our policy engine, right, where we look at vulnerabilities. In the case of open source, we've got a proprietary capability called advanced binary fingerprinting that lets us essentially provide precise component matching. So for us, it's all about number 3 here, right? Is in order for you to innovate, you need automation. In order for your automation to work, you need precise and accurate data. And that's what Sonatype is bringing to the table. Because precise and accurate data allows us to automate faster because we're showing less false positives, less false negatives. And of course, when we get that precise and accurate data, we're now then be able to give context to that data in what we call policies, right? We provide a Nexus Lifecycle provides the policy engine that we can customize, whether it's around vulnerabilities, whether it's around legalities, et cetera. And we also generate the reports, which you'll see here in a minute. In the case of open source, with a histogram of different releases and what might break your code and not. And so, you know, that's kind of the background of how our software composition analysis worked. Now we've introduced Nexus Container, which is powered by our partners, NeuVector. And the reason that we partnered with NeuVector, prior to NeuVector, we were doing a lot of container scanning with open source tooling. You might be familiar with like Claire and Ahab, a few other tools out there. And what we noticed is that we weren't getting number 3. We were getting a lot of false positives from using those open source libraries capabilities. So partnered with NeuVector again, because we don't believe you can automate things without precise and accurate data. And not only did we look at NeuVector as our partner for that, but what you're going to see from Glenn later on is the ability that if you do miss something in development where we're shifting to the left, we've still got you covered with Nexus Container, because there's a runtime element that's going to allow you to get zero trust in environments here. So again, works very similar with our containerization as well as our OSS. So let's actually do a little drive through the product. All right, just sign in here. All right, just show you a little bit about, so everything starts with a root organization. And then we create additional organizations underneath that root. For today, I've created an Acme e-commerce organization. And for each organization, that organization is responsible for applications. Again, think back to the anatomy of an application, right? And for these applications, we have policies, right? A lot of these policies are out of the box, but the wonderful thing is that you can create your own policy. So I can go to my app, I can give it a name, and then I can apply any constraint that has any sort of conditions where they all are met or any are met. It can be based on the age of the component, the identification source, labels that you provide, it may be a license. And this list here continues to expand, and we'll continue to expand it to support metadata and attributes around container as well. Besides being able to create these custom granular policies for your application or your container or your infrastructure as code, we also get to define where in the SDLC we are and what type of action we want to take, right? So maybe if I'm in, development and source, it's a warn, it might even be warn and build, but maybe in stage or release, we start to say, we need to fail, right? So again, shifting left as we're moving right through the pipeline, we can apply different contexts on the vulnerabilities or the legalities we're finding with our containers and open source and infrastructure as code. So once we've done that, then we actually run our scans, and I'll show you. I've already actually run the scans. I'll show you how I ran those, and we generate reports. So real quickly, let me just minimize this. Might be a little difficult to read here, but they're just command line. It's a command line interface. I can script this. I did a scan for my application, a scan for a local image that I did a Docker pull on, a scan of my infrastructure as code. In this case, it was a Terraform plan. And then I can actually combine those, right? So again, if you go back to anatomy of an application, I can get a software bill of materials for my container, for my application, for my infrastructure as code, or I can have a combined software bill of materials for them. All right, so let's look at a report. We'll look at the application here, and let's see, maybe we can look at one of these. This will give us an overview. You can see here we have a version explorer, so I can click and I can see what's the comparison. If I move, is anything going to break? I can look at policy violations here. And this is interesting because you'll notice that this has it's a Sonatype. So 1/3 of our engineering organizations is devoted to data research. Again, it goes down to precise and accurate data. We actually research this and add to those common sources of CVDs. And here you can see the issue is actually something flagged by our research team. Of course, again, we can look at the different CVSs as well as what licenses we're dealing with here. So let's go back. Now we can look at a base image. Actually, let's look at one that Glenn's actually going to show in runtime. You can see, and it's very similar, right? We've got a bunch of Ubuntu issues. Now these are being raised as a 10. Again, it goes back to the policy that I have correct, right? Because I'm saying, hey, if it's greater than equal to a 9, then that's what I'm going to call security critical. And here's my information. And of course, you can actually click out and go to that CVE. All right. And like in the same token, now infrastructure as code is a little bit different. They're not necessarily vulnerabilities. They're more like best practices. So we can look at one and it's going to say, hey, the log file should be encrypted. And so it's really giving you best practices after it's scanning your infrastructure as code. So again, containers, your application, and your infrastructure as code, all in a single control plane, where you can meet those software bill of materials at every point across your SDLC. Now, one of the things, let me go and show you, let's go back to the app, or I can click container, just to give you an idea. This is I just downloaded. This is my composition report for my application, right? So this is my software bill of materials. However, I can also generate this as a Cyclone DX. So we have standardized on Cyclone DX. I know you've got Cyclone DX and you've got SPDX. So we can generate this in an interchangeable manner. And we have APIs, right, where you can pull this data and this information. Or if you're using some other tooling that you're generating an SBOM with, you can actually input that into a Nexus lifecycle, again, providing a centralized control plane for your software bill of materials for all of the pieces that make up your application. So with that, again, just to go over, it's about precise and accurate data. It's about shifting left, being able to catch as many vulnerabilities as we can with development and application security. And you're going to see that when you continue down the pipeline, Kevin's going to show you with Mirantis how they can secure and sign that and move that forward. And then Glenn will show the runtime aspects, which I think are really exciting as well. So thanks for the time.
Thank you, Paul. Hey, Paul, you've got one question before I steal the screen away from you. Okay. This one comes from Suzette, and she's asking, did I hear you correctly that you have a team of people reviewing CVEs and making recommendations?
Absolutely correct. In fact, that is our intellectual property. It's not so much the software, but again, you cannot get automation. Well, you can get automation, but you can have automation with bad data. Which
there's a saying, there's nothing worse than no automation, except automation that's not quite right.
Right. I mean, false positives are, we pride ourselves on not having false positives, right? Because that's a terrible waste of an agile team's time. And that, that's only done. And again, for the application parts, and we're going to be moving there with containers, for the application parts, right, being able to fingerprint the artifacts and components is very unique to Sonatype. And the analogy I give there is, my name's Paul Smith. If I go to a restaurant and I say, hey, I've got a reservation for Smith, they might give me the wrong reservation.
Oh.
But if those reservations are handled by fingerprints, you're always going to get the right reservation, and that's what we do with Nexus Lifecycle. That's
awesome. I mean, that actually is a good question, and I appreciate it. That's a good thing to point out. Sometimes people go, okay, well, great. I have a security risk. I have a CVE. What should I do now? So that kind of advice does come in handy. That's the end of the questions that I have for QA from you folks. Housekeeping. If you have questions for any of our presenters, or if you think of one that might be for Paul, or you don't know who it's for, it doesn't matter. Feel free to throw those questions into the Q&A box, and we'll get to them as appropriate, either in the middle of the stream or afterwards. Moving along here, it's Kevin's turn. Like we said, we've preempted Kevin. Kevin, it's the floor is yours. If you want to steal, you know what to do, man.
Alrighty, thanks a lot, Jordan.
Thank you.
Okay, let me go ahead and essentially steal the screen.
Yes.
Alrighty. Okay. Hey everybody. Hey, once again, good morning, good evening, good morning, good day. So now that let's take this a step further, right? So now that we have a full inventory of our application code, our bill of materials, and then also the infrastructure is set up, right? What's the next step? and really it is to actually deploy it. Now, if you look at the typical application development lifecycle, once you have, let me go ahead and bring my laser pointer up, right? Once you have your code built and put into our containers, you store it in a repository, you'll have lifecycle scan it for vulnerabilities. And once you're happy with that, the next step you want to do is you want to sign it for authenticity, right? So taking the same factory floor analogy, you've got your items there, you package it up, and then you wrap it up so that you know nothing is being changed onwards. The orchestration then takes that and puts it onto the different environments, be it your test environments, your pre-prod production environments. But the thing is, you're going to need some environment for you to deploy it to. And this is where the operations and the infrastructure side of things comes along. So while things are happening on the dev side, the operations folks will go through and using an as a service, a simple platform, deploy the infrastructure onto the various environments. So this involves both your container runtime, your container orchestration, and then look at also things such as lifecycle management. Once it's there and your application is running, the next thing you want to look at is, how's my infrastructure working? Is my environment working properly? And this is your monitoring side of things, where you want to look at your logging, your monitoring, and also alerting, right? So proactively if there's anything going on, you could then go ahead and fix that. And of course, in true DevOps fashion, what you want to do is you want to be able to share that information to both your ops folks, but also your development folks, right? So not only those folks running the factory floor needs to know what's going on, the developers also need to know how their code is actually performing once it's being deployed into the various environments. And that could also be done through the Lens IDE. So this is being done, empowering the developers to be able to see what's going on, right? And it's no longer just the operations folks that's looking at this. So as you can see from this diagram, then there is quite a big attack surface. Forget about the code itself, even just the infrastructure. There's so many different attack vectors. So how do we ensure everything is secure? Now, when you think about infrastructure security, and a lot of organizations do a great job securing their infrastructure, but there are many that falls into one or two categories. One where they're unaware that their clusters are insecure and thinking they're as good, or two, those that know they're insecure but not sure where to start. So to mitigate that, we could do a lot of the mitigation by taking action in 4 different areas, like you can see over here, right? One, you want to secure the cluster, the underlying infrastructure, and also the admin tools, right? Don't ever forget about that. 2, control access to the people and the workloads onto your environments. And then more of the best practice side of things, right? You want to provide a secure software development process that lets developers build and improve software quickly, and really think about consuming only appropriate components. And these are things such as your various container image layers, right? Things that are authorized for use. And that'll prevent malicious execution of workloads on your clusters. And last but not least, you want to build a secure DevSecOps culture where you're really thinking about security throughout the process. Things such as your best practices, your architectural patterns, standardizations, or even tools that make sure that your code is more efficiently and securely run on Kubernetes, right? Bring that automation aspects into it so that you don't have to have some poor person staring at the screen every single time, right? So again, if there's any questions, feel free to ask in the chat window, and I'm pretty sure Jordan is going to relay it over to me. But let's dive a little bit deeper into the first one. Jordan, let's see your mute.
Well, there is a question that came in, and it feels like it could be a general question, but you're the one with the talking stick right now, Kevin. So you can grab it as you feel. Our question is, how does STIG and FIPS fit into everything else with security? I see your knowing face. Looks like you're ready for this one.
I love that because that kind of fits into what I'm about to talk about. So I'll dive right into that in a second. But if you think about FIPS and STIG, right, one is a standardization for encryption, and the other one is a set of guidelines and best practices and all. And again, I'll dive right into that in a few slides. But if you think about, let's look at the first area though, securing our cluster. when folks think about security, normally what we think about is the application layer security, code level security. But now with Kubernetes and containers as an added layer, we also have to think about orchestration security. So if you look at the way Kubernetes is set up, right, there are a number of attack vectors, such as the communication between your API server, the Kubernetes API server, and the kubelet, the access to the API server, or even access to your workloads through your ingress, right? So those are also things that we need to look out for and could be potential attack vectors, right? So now you've got your application secure, but if the underlying infrastructure is not secure, there's going to be a problem. So what do we do with that? And this is what Mirantis brings to Kubernetes, and this is how we can offload some of those efforts from you, right? Because if you think about it, security is very important. We all know that, but a lot of times it's kind of an afterthought, and not because it's not important, but because folks just don't have the bandwidth, right? We're so busy trying to either fix bugs, push out the next release, making sure everything's up and running, that just keeping the lights on is actually taking up most efforts, right? So how can we help? With Mirantis, we could provide automatic deployment with continuous delivered lifecycle management, okay? So these are things such as your updates, your upgrades to your Kubernetes runtimes, your environment, and making sure that everything is up to date. Pertinent to our topic today and the question that you just asked, we have extensive security enhancements to the infrastructure products. So there is built-in identity access management. There's role-based access control integrated into the products. FIPS 140-2 and DISA Stick, which again, I'll dive a little bit deeper into, and also vulnerability management. And also another point is we also provide proactive support with guaranteed outcomes. And this is unique in the industry. So where we'll work with you to determine the business priorities and provide guaranteed outcomes such as availability, SLAs, uptimes, and so on and so forth. Okay. So diving now, that's a long introduction to the question, but let's dive into FIPS 140-2 and what it's all about. Now, FIPS 140-2 is the Federal Information Processing Standards, and it's a US government computer security standard used to approve cryptographic modules. As you can see on the screen over here, there's 4 different levels to the certification, starting from level 1, where the individual components are secure, and these are things such as your encryption, your communication, and so on, all the way to level 4, where the entire system is hardened. So you've got your application, your communication, even your hardware, and it really depends on what level you're trying to achieve. And who really needs this, right? But first of all, it's developed by the US government, so therefore the US government, or even just government agencies in general, where you need heightened security. But also in regulated industries, such as your finance, telcos, healthcare, right? With HIPAA in the European region, you've got GDPR and so on and so forth. But really, if you think about this, in this day and age, really any industry that has access to secure data will really need that, because we've all heard of these outbreaks of our system's been broken into and all these payment card information has been leaked, right? All these access and password information has been pushed out. So you really want to make sure that there is no chance whatsoever for your business reputation to be tarnished by these sort of attacks. Now, how does that apply to the infrastructure that we provide, though? So at Mirantis, we've got FIPS 140-2 verification on a couple different levels. One, the container runtime, and this is where your containers will be running on. And so that communication between your different nodes and pods, they're all encrypted fully. One level up, the Mirantis Kubernetes engine, which is the orchestration layer, including both Kubernetes and Swarm, are also FIPS 140-2 verified, so that the communication between the API and the kubelets, all of that is being locked down. And there's also K0s, which is a lightweight Kubernetes engine. This is more of a standalone Kubernetes. It's upstream CNCF certified and also can be used for edge use cases as well. And how that really helps you is that now for any of you that wants to pursue certification as well, we save you time by providing the underlying infrastructure. So you can now focus on what you do best, which is your application security and certification on that front. And we'll just kind of make sure the infrastructure gets out of your way of your certification, right? So it saves you time and effort with having to define your own standards and also certify your own stack. Now to the second part of that question, what's a STIG? I mean, what's that all about? So the DISA STIG is a set of technical implication guidelines that is been defined by the Defense Information Systems Agency. So it's a list of checklist items and questionnaires and guidances on kind of best practices and of locking down your environment. Once again, who needs it? Pretty much the same as the previous group of people, right? And the difference, if you think of the relationship between FIPS and the STIG, is the FIPS is making sure that all of the components are secure. The STIG is how do you apply that onto your environment? So you've got your secure components. How do you put them all together so your entire system is secure? So the certification process it's pretty significant technical work, and there's a long approval period. And we've actually worked with the government agency to actually certify an earlier product release of Mirantis. And what we're working right now is to make sure that our current version is also certified and aligning with the current STIG contents. So once again, what that means is now you know that the system that you're running your code on is not only secure in terms of communication, but also secure in its implementation and its composition, right? So making sure that the entire system is secure so that it's not getting in the way of what you're trying to achieve. So what does a STIG kind of look like, right? Some examples will be like, so you could actually, if you're in the US region, I believe you could download the STIG to view. If you're outside, I think there's a public facing one. The contents might be slightly different, but you kind of see what's going on in terms of what the requirements are, right? So for example, let's say your Kubernetes control manager must use TLS 1.2 at a minimum to protect the sensitive data going through, right? And also other checklist items such as, your API server must be, has the insecure port flag disabled. So these are configuration items that you want to make sure that you check off, okay? So again, if that, hopefully that answers the question, or if there's any additional kind of clarification needed, please let me know, and I'm happy to go through that or take that offline as well. Okay. So once you think about this, then we got the security aspects of it. How can we help you off with setting up the environment? So at Mirantis, we believe that we like to help you ship code faster and provide value to the customer and also the business, right? And we build that on 3 different pillars. One, we want to make sure that it is simple, right? Simplicity. Want to provide an elegant, consistent cloud experience across all clouds, be it public, private, or even on bare metal, right? Making sure that setting things up is supposed to be an easy task. You don't want the cognitive load of switching back and forth between various environments. Choice. You want to be able to make sure that you can you're not locked to one single vendor or one single environment. So, if you choose the technology that you want, you choose the technology that makes most sense. Because we're CNCF certified, it is actually swappable as needed. And last but not least, and pertinent to what we're talking about, security, right? Making sure everything is secure so that we got the built-in security so you don't have to worry about that moving forward. And all that creates a DevOps as a service platform. So this is a platform for developers, for operations, in both containerization and virtualized environments. And along with our partners, such as NeuVector, we provide a holistic containers as a service platform, and we're able to help you achieve value faster. So with that, before I dive into a demo of what that would look like, or how the entire process will look like, are there any questions or additional questions that you see there?
I don't have anything else rolling in the QA room. Everybody else who can hear my voice, feel free again to drop stuff in the QA. All three of our presenters are not only brave enough to try to do live demos in a live in a live presentation room, they also love the challenge of questions coming in on QA. Thanks. All right, may the computer demo gods smile upon you, Kevin.
Awesome, thanks. All right, so let's take this from where we were talking about, right, in the diagram. So you've got your application software bill of materials come in, and your container image is now storing in the repository. So what you're seeing here is the Mirantis secure registry. And as with all Mirantis products, we got built-in role-based access control. So you see here, over here, it's again based off organizations, and there's only two different users that can access it, myself and a automated user. And if I go into my registry, I could then go ahead and see, here is the image that has been checked in to the registry. You can see that there are a number of vulnerabilities that we've seen from the lifecycle scan, and we've got a digest number that is attached to the container, right? So I look at this and say, yeah, you know what, that's good enough. Let me go ahead and sign that. So the active process of signing means that whatever you've got in here is now verified for use in your environments. Okay, so as a signer, I could go ahead and just say, you know what, let's go ahead and sign my image. This will take a little long, I have to connect, and fingers crossed. Oh, let me do version 1 instead, and I am going to have to do this again. Here we go. Right. So I'm missing a version. Here we go. Okay. So once I go ahead and sign that, I'm going to make sure I put in my passwords so that no one else can actually act as me. And we got a signed version of the image. I'm not going to sign my version 1.1. Let's use this one instead. Okay. So the active signing then means that I could then control what goes into my environment. And when you're thinking about security in your pipeline, you want to make sure that every single container that you are working with in your various environments, right? Right now I'm in dev. So if I want to promote this production, we want to make sure that we're actually promoting an image and not rebuilding an image, because now once you're doing that, you've made changes. You don't know if that's going to be the same thing. You don't know if it's going to be as secure as before, or if it's going to actually perform the same way as before. Kind of takes away the purpose of having containers. So what I'm going to do is I'm actually going to promote my version 1 then into my my production environment. Okay, so once I go into my image, I could then go ahead and promote it to whatever repository I want. So I'm going to promote it to my prod environment, and let's make this. It's going to go into Node, and let's call this v1 as well. Okay. So the active promotion then takes that and then moves the entire image as it is to our production environment. At the same time, you could also set up rules so that you can do this automatically, right? If you have things such as, I want to promote this if my scan says there's less than 2 vulnerabilities or less than 2 low-level vulnerabilities and so on and so forth, I could then set it up so that it automatically promotes as well to a different environment. Okay. Now, while that's happening from the dev side, let's have a look at how we can then provision the infrastructure for these images to be provisioned onto once your workload is ready to go, right? So what you're seeing over here is the Mirantis Container Cloud. This is the management layer on top of your various different cloud environments, so to speak, okay? And let me quickly create a cluster. I'm going to create a new Kubernetes cluster that I can actually use. And as you can see, there's a number of different choices. You're not locked into just one environment. We got AWS, Azure, Equinix Bare Metal, even on vSphere, right? If you're working on the VMware environment. So let me go ahead and provision one onto Equinix. And you see now, instead of having to go through and script everything out, what I'm going to do is simply type in a cluster name, demo. I'll put this on Equinix, why not? Okay. Set up my SSH key so I can actually access the machines if I need to. So let's go ahead and put that in there. And I'm going to say, yes, this is good for a set of network, and going to enable my logging as well for my Stacklight, so that once my cluster is provisioned, I could then go in and have a look at the performance of the infrastructure. Now that the cluster is there, I've got the shell. What I want to do next is let's go ahead and provide some provision some machines onto it. So I'm going to let's provision a quick high availability cluster. So I'm going to put like 3 manager nodes onto it. And yeah, this is a good machine time. That's fine. I'm going to go ahead and create that. Now go ahead and create 2 worker nodes as well. And really quickly say, yep, there you go. Create, and that's it. We're going to let it do its thing, and hands off. I could go and have lunch in a second, right? And then come back and see all of my machines provisioned within the cluster. Now, what happens though once you have provisioned it, and I want to go ahead and manage it, right? So let's have a look at my AWS environments. We'll let the Equinix environment do its thing. Okay, so over here I've got again my HA environment. I could then go in and manage my my orchestration, right? So I'm going to go into this is the Mirantis Kubernetes engine, and this is the orchestration layer that runs in your cluster. That let's go ahead and sign in really quickly. Okay, again, built-in role-based access control so that everything is integrated. And I'm going to say yes, right? So this manages the orchestration side of things, and it has support for both Kubernetes and also Swarm if you're doing Docker Enterprise orchestration. Okay, so as you can see over here, I've got my nodes, they're ready, good, everything's up and running, happy with the performance. And I'm going to make sure that I only provide access to whoever I need. So this is, remember, controlling access to people and also workloads to your environments, right? So built-in RBAC, so it's not, you know, it's more of an opinionated side of things when you're setting things up. At the same time, what I could also do is lock down my environments. So I've got my people side of things controlled. Let's look at the workload. Okay, so I can set up content trust so that only signed images can be deployed onto my my nodes, right? So this way, let's go ahead and configure that. So this way, no unauthorized workloads can be provisioned onto your environments. I'm going to run that. Okay, simple as going into the configuration and flipping a switch. Okay, so who said security is hard? Okay, now this is good. Now we've got all of our, I've got my image ready. I've got my environment ready. I could probably have my pipeline set up so that it provisions automatically. But let's look at this from the developer side of things, right? I'm starting to do my development. Everything looks good. Let me see if I could test things out. Now, as we know, Kubernetes is powerful, but the barrier of entry is sometimes relatively high just because of the, I won't call it complexity, but the vastness of what it can do, right? And with someone going into Kubernetes starting off, there's a universe of information. It's usually quite overwhelming for some folks, right? So what we've done was we've made it easier through what we call a Kubernetes IDE. And this is Lens, what you're seeing over here right now. And this kind of brings a UI aspect into Kubernetes, right? So what it not only does is provides developers visibility into the clusters, as well as kind of lowering the barrier of entry into Kubernetes, right? So what you can see over here is I'm actually connected to the cluster, my AWS cluster that you saw just then. And ooh, hang on, there's a warning. I did a deployment yesterday. There's some issues going on. Let's see what's going on with it. So let's have a look at my my nodes. Well, everything seems to be fine there. Let's have a look at my workload. Okay, so I've got 3 pods. My replica set, there's a pending. What's going on there? Let's have a look at my events. Okay, it's trying to pull an image, and there seems to be an issue with the image. All right, let's have a look at it. So let me go into my replica set and see what's going on. Well, I've got 3 desired. That's all fine. Oh, hang on. That's it. My image, fat-fingered. Instead of doing my V1 deployment of node, I've put in the wrong image I'm trying to deploy. So let me go ahead and try to fix that. Okay, I'm going to click on Edit, and let's find my image here. Cool. Let's go ahead and fix that. I'm going to deploy version 1, which you just seen in the registry. Save that. My replica set seems to be updated. Let's go to my pods and see. I think right now it's still trying to use the wrong image. Yes, it is. Let's go ahead and get rid of those pods. Right, so delete those, let my replica set refresh and deploy new ones. And hopefully it should be up and running. And everything is green, plus last one is still lingering. Let's give it another minute to go through. Okay. Oh, great. Now I've got my 3 pods running. But I know my workload is going to be a bit more than just the 3 pods can handle. So let me go ahead and really quickly fix that replica set. And let me scale this up and say, okay, you know what? I'm going to need 7 replicas running at the same time. Do that. And let's have a look at it automatically deploy in the environments. And there you go. Okay. So with this, like I said, it greatly lowers the barrier of entry into Kubernetes, because now you don't have to think about, okay, I've got to do kubectl. What are all the different commands? I've got my screen up and running. I got to look at the right command to go through. I could then come in and have a look at all the various things that are available to us, my network services, what's running, or even namespaces. And I could actually create all that using the UI and making my life a lot easier as both the developer and even the operations folks looking at the different things. And yeah, so that is pretty much it, right? So if you think about this now we've got our infrastructure secure, the next thing really is to look at what, when the application is running, how do we look at the runtime side of things? So pause a little bit then, and that's pretty much it. So if there's any questions, Jordan, back to you, I guess.
You have no inquiries currently sitting in the queue, but I will remind folks that don't be shy. If you want to pop them in a little bit later on, that's easy to do. All right, now comes the point where we're going to do, a little bit of yoga. I am just kidding. We're not doing any yoga today. We're all big girls and boys. We can get up and stretch as we need, but I remind you to stretch. Thanks, Kevin. Really appreciate that. It was very valuable. I saw your little comment who said security is hard. And I was also noticing, we talk about things like compliance and security, and sometimes people mush those two things together. But I've seen a lot of organizations that are stuck, with compliance raining on down them, that if compliance is difficult, they're constantly working on that. And the other security things that enhance security inside of their organization don't get pulled together. So, being able to match your compliance quickly and easily allows you to enhance your security posture a little bit better inside of your organization. And speaking of security posture, as we shift further along into runtime, Glenn, the talking stick is yours. Looking forward to this.
All right.
Yep.
Thank you. All right. So as I mentioned, I'm very excited about this whole topic today, which is really looking at the entire pipeline of security all the way into production. And the reason that's so critical is as many financial services and government agencies know, you really need a layered security approach. And there's many layers of security, there's many places where hackers can try to get into your infrastructure. So I'm going to focus on the bad stuff that can happen once you're running in production. Once those critical workloads that are handling your business critical logic or sensitive data are actually running, how do you protect that from the hackers getting in there? Now, before I dive into the production side or runtime side, let's take a little step back and let's recap the entire attack surface of the life cycle of a container. You heard from Paul about all the bad things that can happen in the dev stage, how critical it is to manage open source artifacts and licenses and look for vulnerabilities very early in the pipeline and prevent them from even getting into a registry, because vulnerabilities can enter really at any point in the pipeline. And then we also heard from Kevin how critical it is to be able to, with Docker Content Trust and RBACs and things like that, to lock down the that middle stage, the infrastructure itself, the orchestrator, as well as prevent images that are unauthorized from getting into the production environment. And so that really addresses some of the misconfiguration risk that can occur anywhere in the pipeline. But probably most damaging is if you have not properly set up your RBACs in Kubernetes, then somebody can just log into your management console and start doing crypto mining like we saw with the Tesla hack a couple years ago. Now, in the production environment, not only do we have to make sure that we've done everything up to that point to make it as difficult as possible for hackers, but we also have new attack surfaces. And that could be the orchestrator itself or other tools. Could be the runtime. We've seen critical man-in-the-middle vulnerabilities in the API server last year in Kubernetes. So that could be the orchestrator, or it could be any of the tools that are being used in production to manage that environment. So that's a new attack surface. It's very new and early in its life cycle. So the hackers are just rubbing their hands gleefully, waiting for production and deployments of all of this new cloud native stuff, because there's a new attack surface and they are going to try to find holes in all of that new software. And then we have, of course, the traditional application environment. In this environment, instead of applications running on VMs, it's containers running on top of these orchestrators. And so the containers can be attacked. The container network can be used to expand the attack, and the applications themselves can still have application vulnerabilities, even common things like Apache struts hacks or SQL injection attacks or cross-site scripting. Those all still exist. They don't go away just because you're using containers. So how do we protect against all of that? So as we talked about in the very early stage of the process, vulnerability and compliance, registry scanning, locking down your infrastructure, and making sure you're auditing how those RBACs have been set up. We heard from Paul about how Nexus Lifecycle can use the Nexus container scanning early in the pipeline and then build that or take all of those results into the lifecycle policies and then do enforcement there. Now, as we move into the production environment, we need to run the CIS benchmarks, whether it's the Kubernetes CIS benchmarks or the AWS, Azure, GKE CIS benchmarks, to make sure that everything is configured properly and doesn't stray or drift out of compliance. Also, it's critical for many companies to maintain or achieve and maintain industry compliance like PCI, GDPR, NIST, et cetera. And then when containers actually start to run in that runtime environment or your orchestrator, Kubernetes, it's critical to keep up to date on any vulnerabilities. And they could be newly discovered vulnerabilities after you've been run those workloads through your pipeline, you've updated to a new Kubernetes release, and new vulnerabilities are disclosed. And so we need to know what those are and how to remediate those. But ultimately, it's critical to put in runtime protections because no matter how well we do in the preventative side of security, there's always going to be zero-day attacks, misconfigurations possibly, or just bad things that can happen. So really your runtime defense is your last line of defense from somebody bringing down your application or stealing sensitive data. So the link between that test or pipeline environment and the runtime environment really starts with admission controls. And Kevin touched a little bit on that, which is the ability to make sure only signed and trusted images are allowed to be deployed into the production environment. And we go a bit further to offer other criteria that can be used to set up rules to either allow deployments or to block deployments. And as you'll see in the demo, that can be based on things like vulnerability scan results, CIS benchmark configuration results for the image related CIS benchmarks, or it could just be simple things like PSP policies, don't allow privileged or root containers, or other criteria in the actual deployment of a container. So that's your first gate into the production environment. Now, once your workloads are running in production, it's critical to be able to get visibility and protection into the network connections and the network activity that all those pods and containers are generating. And in addition to that, it's critical to monitor every container and pod for all the process activity and all the file activity. And that's what is provided in the Nexus container runtime solution, which is powered by NeuVector. Now we take what's called a zero trust model. And part of that, of course, is what Kevin talked about, which is proper RBAC controls and defining exactly who gets access to what resources. But for a runtime environment and for application pods, a zero trust model really is involved with defining what network connections and what protocols are that application going to be allowed to make, as well as what process and file activity can that application container start or generate once it's running in production. And so instead of scanning for bad patterns or signatures or malware, we take a different approach, which is the zero trust model, which is define what this workload, what this replica set is allowed to do, and everything else is untrusted and can either be alerted or blocked. Now, so it's a little bit of a shift of thinking for the security, the runtime security community to move to a zero trust model. And you can imagine that when you're deploying hundreds of application microservices and updating them thousands of times a month, perhaps, it can be difficult to keep up this zero trust model. How do we keep it in sync with what the applications are expected to be able to do? So for that, we need to automate the entire pipeline. We need to, just like Kubernetes, you're going to deploy how your application and what kind of resources it's going to ask for Kubernetes. We need to allow application deployments to declare what type of behavior is going to be allowed in my application. And that can be then pushed into the security layer of the infrastructure to define that allowed behavior. So to be able to make this easier for the dev and DevOps teams, what we need to be able to do is have some behavioral learning and automation in place. And that's basically the process of running your application workloads in a test or a staging environment and letting NeuVector learn all of its behavior, learning the network connections, what protocols are being used, where they're connecting to, as well as all the process and file activity, and then generating that zero trust allow list of behaviors. That can then be reviewed, exported, edited, and then codified as security policy as code, which is essentially a YAML file, a CRD YAML file that declares what that microservice is allowed to do once it's deployed. And that can be treated as code, checked into your Git repo or your GitOps process, just like the deployment YAMLs are managed as well, and pushed into your production environments. And anytime there's an update to the application that requires new behavior, especially of the allow list, then the same process can occur. You can either go through the learning process, or if it's a very simple change, that YAML file can be checked out, edited, run through the tests and the new application test suites to make sure that you're getting the correct protections and behavior, and then promoted into the production environment. So that is how security can be automated and keep up with this new rapid deployment environment of some of these cloud native infrastructures. Okay, so with that as a backdrop of the security aspects, now I talked about the zero trust model. Sometimes we call it the ability to do virtual patching, but it's really more than vulnerability patching or which is commonly associated with virtual patching. Now, if you're able to define what your application is allowed to do, not only can you prevent attempted vulnerability exploits in the production environment, but you're also able to detect and prevent things like zero-day attacks. If there's embedded malware that somehow is able to get through your pipeline, or there's many cases published in the last couple of years of secret backdoors in container images in popular Docker repositories, hidden backdoors that allow somebody to get in and then maybe get out to a command and control server. Any of those types of exploits are going to be able to be detected and even blocked with this zero trust model. So in this model, not only can we learn the network process and file activity and lock it down, but once it's locked down, any attempt to have malware start or to exploit a vulnerability is going to be able to be detected. And remember that a successful attack or hack is not just a single security event. It's what we call a kill chain. So the attacker gets in, they use the network to get in. So that's one point at which we can determine, oh, this is not an authorized ingress network connection. They use the network to expand the scope of an attack. So maybe it's a segmentation rule violation that can be detected. They can then either try to connect to a command and control server, start up a malicious process, even the starting of a remote shell will be able to be detected either from the process starting or from the network connection. So there are many points in that kill chain where we can detect that there's a security event happening, and there are many opportunities to detect and block those attempts. Of course, we believe that the network is the most critical threat vector that needs to be, you need to have visibility into and to be able to monitor and prevent these types of attacks, because they're going to use the network to get in, to expand, to get out, maybe to command and control. And then ultimately, if they're trying to steal sensitive data, they're going to use the network to try to siphon data out of your infrastructure. Now, we get a lot of questions about, okay, well, a lot of, whether it's compliance, regulations like PCI, they require some of these traditional security tools and functions like malware scanning or IDS IPF or WAF, of course, vulnerability management. So while we do provide many of these functions in the NeuVector platform, a lot of these are prevented effectively with a zero trust model. So if somebody is trying to connect to a command and control server that requires a next generation firewall to block that, by moving to a zero trust model where we only allow certain network connections out of the pod, we essentially are satisfying that requirement for a next generation firewall without having to actually deploy a next generation firewall at the edge, which is your traditional security control. And the same goes for IDS IPF, WAF, or malware scanning as well. That malware scanning is not so critical in this environment if we can detect any malware that is going to start up by detecting a malicious process that starts up in a container, or a resulting connection that's attempted to be made as the malware tries to either expand or connect outward. So it's important to understand how we can map some of those traditional security controls into these zero trust models. And we have been working with many companies and their PCI auditing consultants to get approval for mapping these types of functions to this new zero trust model and satisfy those types of requirements. Now, before I get into the demo, a little bit on the architecture and deployment model of NeuVector. You heard from Kevin on how to deploy not only Mirantis cluster, but workloads on top of that. And NeuVector is really just another application that can be deployed by whatever means you're using to deploy your applications. Whether you're going through Mirantis to do that, whether you're using Helm charts or just kubectl commands, that's how you deploy and manage NeuVector. So the architecture of NeuVector is very similar to Kubernetes in that there's a control plane using the same protocols that Kubernetes uses to sync the controllers. There's a leader elected, which is really the main brains, but the others are there for HA. And the controllers, when we are doing scanning of images in registries or the pipeline or runtime scanning, send scanning jobs out to a replica set of scanners. So that can be scaled up. You can use your replica set scaling that Kevin showed you to scan that up to 10 scanners. If you have to scan 10,000 images in a registry because you have a new CVE database update, you can scale it up and get that done really fast, whereas other scanners will just not complete that job. There's a kind of a stateless management console that uses the REST API that's exposed by the controller to do all of its setting of policies and logins and anything you can do through the console. But you don't need the web UI. You can do everything in NeuVector through the REST API and things like CRDs. The real workhorse of NeuVector and Nexus Container, I should mention, is the enforcer. The enforcer is a daemon deployed as a daemon set. So anytime you scale up the number of nodes in your cluster, Kubernetes will put another enforcer on that node. And the enforcer is going to do all the packet filtering, all the network inspection, the network protections, monitoring of all the process and file activity on every node, all the containers of that node. It's also going to do all the host scanning that we do, vulnerability scanning of the host, any compliance, CIS benchmarks, any scanning, vulnerability scanning of the pods themselves. Is going to collect that information and then send it to the scanner and controller. So that's the NeuVector infrastructure, and I will now jump over to my demo of Nexus Container. So this is when you enter NeuVector, you're going to enter at a dashboard. And the typical mode in NeuVector is the default is really designed for a test or staging environment where we're going to learn all that behavior of your applications. But once you've locked everything down, things are going to be in a monitor protect mode. And we're going to give you a security exploit risk score. You can see here it's a fair in this environment, probably because I don't have all of my pods in the NeuVector protection mode yet. I also have some ingress and egress connections that have had some network issues. So that gets factored into the score, as well as, of course, vulnerabilities in the runtime environment. So we do provide this little wizard to step you through improving your risk score. You can just step this through, and this will help you to reduce that risk of exploit in your runtime environment. We also provide you a summary of ingress and egress, because those are really critical connections. If anything is getting in or out of your environment, in this case, kube proxy is probably trying to go external to try to connect to an external server. We want you to know about it and either explicitly allow that or start to put it in the protection mode where it's going to be blocked. We also provide you an analysis of all of your network traffic by application protocols detected and the volume of network connections going through any of your special protocols. So this is something else you can monitor for unusual behavior in any of your protocols. Could indicate that there's a network hack going on. Now, we summarize all of the network activity in a visual display, which is really a live real-time view of all of your network connections. You can imagine in a complex environment that you would have a lot of these containers. So we'll automatically collapse namespaces and groups if we start to detect too many applications and containers and pods running. But you can also filter them down like I'm doing here into various namespaces. So here I can see I've got my Node.js containers. These are the ones that Paul and Kevin showed in the pipeline and that are now running in my production environment. I can see the red dot means that there is a bunch of vulnerabilities in this container, detected in this container. You can see all the details of the vulnerabilities and the various other details of the deployment of this container. Now, you can also see if we are detecting any suspicious connections. So the red and the orange connections are connections that we have detected are either violating segmentation rules, the allow list, or they're network attacks, built-in network attack detection for DDoS attacks or SQL injection attacks or other types of attacks. And you can see we can show those here. We can also show segmentation violations. So for example, this Node.js pod was trying to connect laterally to another Node.js pod, and we blocked that. And the reason that any connections would be blocked is number one, that it's in a protect mode, which is like an inline firewall mode. And number two, there's not an allow list rule to allow that type of connection. So in blue, we can see what types of connections are allowed. And these are the types of connections that were learned in that discover phase. So here I can see that my Nginx pod is allowed to connect to my Node.js pods. And there's a rule that was automatically created, rule number 4, to allow an HTTP protocol between Nginx and Node.js. And we can also see that the Node.js then connects back to the Redis pod using the Redis application protocol. And there's a rule 22, which was automatically created to allow that. So that's kind of a quick overview of how some of the network segmentation, learning, and threat detection works in NeuVector. Now, at any point in time, I can select a container. I can see the details. I can see the active network sessions. That's also useful for debugging. I can start a packet capture. And so this is kind of like a TCP dump PCAP capture that can be downloaded as a PCAP file. You can start it for a set amount of time if you're noticing suspicious activity. And what a lot of our customers do is to automatically turn on that packet capture if any type of suspicious activity is detected for some amount of time. And then later they can have that for forensic investigation. You can also quarantine containers. If there's suspicious activity, a quarantine will block any network connections in or out of that container, leaving it up so that you can kube exec into it and then be able to pull its data and logs and see what's going on in there. So there's a lot of great things you can do from the screen that are a result of all of the policies and connections that have been set up prior. Now, taking a little bit of a step back, if we look at the infrastructure, we can see the Kubernetes versions. There's no vulnerabilities in this, which is great. I've got some vulnerabilities in my hosts that I'm running. I've got some compliance violations as well. And then I can also see for every container that's running, I can see runtime vulnerabilities as well. I can see the process activity, statistics on containers as well. So there's a lot of rich data that is provided in just the asset view. Now we talked about registry scanning, and this is really the first place that you can monitor for new vulnerabilities and then connect that to admission control policies. So if we look at the same image that, that Paul and Kevin highlighted, this Node.js container, we can see in this layered scan, there's a 407 critical vulnerabilities. You saw that back in Nexus lifecycle, but we can see in which layer these vulnerabilities exist, so that if we need to provide specific instructions to the dev team about how to remediate these, it makes it easier for that. And then you can also see an inventory of the all the modules, packages, and libraries and the number of vulnerabilities. In this case, 2 fixable, 4 total that exist in this library here. Now, this is another good point, which not all critical vulnerabilities have patches available for them. Sometimes you're going to have to run images with critical vulnerabilities in the production environment, and you're just going to have to rely on the runtime protections of NeuVector to make sure that those are not actively being exploited. Now, in addition to that, we're going to run a bunch of compliance checks on the image. A lot of the CIS benchmarks, you can see the reference list here. But we'll also look for certain types of things like secrets in images and let you know if we detect things that look like secrets or if certain file permissions are not appropriate. And so once we have scanned our production registry, we can also then tie that to the admission controls. And here we can say if there's any critical vulnerabilities with a fix that were reported more than 7 days ago, then block that deployment. Because 7 days is enough time, I've decided, for my dev team to remediate any critical vulnerabilities where there's a fix available. In other words, there's no excuse for not being able to push that through the pipeline. So I'm going to block all those deployments. But you can see here under the criteria, there is a number of different criteria that can be used, some of which are based on scan results from the image scan that we just saw, and some of which are based on scanning or evaluating the deployment YAML. When that deployment actually occurs, we're going to look at things like, what registry is it coming from? What namespace is it going into? What mount volumes is it trying to mount? Or even just a generic set of PSP best practices can be applied. So there's a number of criteria that can be used to either allow or block deployments into the production environment. So I can show a quick demo of admission control. Here you can see my NeuVector pods in this environment: 3 controllers, 4 enforcers, manager, scanners, and updaters. And you can see my demo pods running as well. I can also just show in a different namespace, I'm going to try to deploy the same Node.js container into this admission demo namespace. All right, so you can see here, there's an error. We're using the admission control webhook of Kubernetes. denied the request, creation of Kubernetes deployment is denied. So if we go into NeuVector, we can see under, this is categorized as a risk report, you can see why this was denied. Rule ID number 5 with criteria, CVE high count with fixed greater than 7 days, hit that rule, and therefore that deployment was not allowed. Now, for any admission control allowed, if there's any containers that have been allowed, as soon as those pods start to run, NeuVector is going to start to protect it. It's going to do a vulnerability scan of that running container, compliance scan as well. So other rules can be set up if anything gets by your admission control rules. All right, so once things are running in the production environment, under policy, under groups, this is where all the runtime protections are going to be managed. So if I look at in my demo environment, I can see my demo stack and Nginx talking to Node, which talks to Redis. And I can see the network rules that have been learned. You can see here a DNS lookup is allowed. It's allowed to connect to Redis, and Nginx can connect to this. So both the source and destination connections are listed here that NeuVector has learned. In addition, NeuVector has learned a number of processes that are allowed in this container. And the same can be true of network and file access rules. Now, one thing I did want to highlight that's really critical is egress control, because you're going to have a lot of pods that need to exit out of the cluster legitimately. And again, you need to declare that allowed behavior. That may be connecting to an API service outside of the cluster, another container, a VM, or even the internet, allowing connections to the internet. So you can see here, there's a rule here that was custom created that allows my NeuVector to connect to my NeuVector, or sorry, my Node.js pod to connect to my NeuVector API server, and but it must use an SSL connection. So the way I did that was I went into my my groups, and I created a custom group called my API NeuVector. And if I edit it, you can see how that was defined. So when you're defining egress controls, you can define that by DNS name, which is the preferred approach, because IP addresses can change, or it can just be the IP address subnet. So if you're connecting to a bunch of applications that's running somewhere on a server or a subnet, you can allow connections from your pod over a private network into a different infrastructure. And once you've created a custom destination group like this API NeuVector, then you can go into the network rules screen, and you can see here, this is the rule that allows just my Node.js pods to connect externally to using an SSL connection. Now, everything else should be blocked. So if I go back into my environment here and I look at, just a sample external violation, if I'm just going to connect, arbitrarily outside of the cluster, this time to google.com, that's not going to be allowed. So you can see here my connection is not going through. And let's see what I'm seeing in NeuVector. So under notifications, security events, I can see an implicit deny rule was violated. That means there's no rule allowing this external connection. So if I click on where it's going to, I can see that it's trying to go to Google. Maybe as you're testing your applications, that should be allowed, and then you could whitelist that rule very easily by clicking a few buttons there. Now, in this view, I can also see that this Node.js pod just now tried to connect to Google. So I can see this violation here and that was blocked. Now, if I go back into here and if I so I'm going to connect to my NeuVector service and I get a response there because I was using SSL. And I go and I refresh the screen here. So we can see that where is my Node.js pods? I can see there's a connection here to this custom group that I created. Which Node.js pod was allowed to connect, this one right here. And so I can see that there's an SSL connection just done now, and it hit rule number 12, which is why this external connection was allowed. So this is a very important way for managing. You can do this for ingress as well as egress control. Now, other things I'll highlight are you can apply DLP sensors, which are looking for either sensitive credit card information in network payloads using deep packet inspection, or you can look for network types of attacks like OWASP top 10 attacks, like cross-site request forgery, cross-site scripting, even SQL injection attacks. So a lot of great things that you can do in the network connections. Now, let's say this is my staging environment and I have decided that what I want to do is, I'm comfortable with how this is all set up and tested. I want to now promote this as my declarative security policy as code. So I'm going to select this stack and I'm going to export this as a policy group. And I'm going to save that. So this is what I talked about, which is the CRD YAML file, which expresses all of the allowed rules that we just took a look at in the NeuVector console are now expressed as this human readable YAML file. And so this can be reviewed by your dev team or your DevOps team. And let's say Nginx is going to connect to Node. I'm not only going to allow HTTP connections, but SSL connections. I can simply annotate that, save it, and push it into the environment. And now SSL connections will be allowed. You can see also where we are defining processes that are allowed. This one's the Nginx processes that are allowed. Again, I can edit those if I don't want to allow those. Here I can allow my egress to NeuVector.com, and like if I'm using a curl process to exec into this Node.js pod, but maybe I was just using that for test. So if I don't want to allow curl in my production environment, I can simply delete that process as being allowed in the Node.js container. So I can save this, test it, and check it into my production repo for the security policies for this application stack. And when I'm ready to promote this into the production environment or into another environment, maybe a mirrored production environment, I simply check it out and push this kube control, apply this. And all of these rules that we see here will show up in that production environment. However, in that production environment, if I look at these rules, for example, these say learned rules for the network rules. And instead of these showing up as learned rules in my production environment, they're going to show up as CRD rules. And what that means is I can't go in here as a local admin and change any of that, because the CRD, that YAML file really needs to be the declarative state of the security rules in my production environment. So if I want to change any of these rules and update them for a new application, I'm forced to check out that CRD file, edit it, and then kube control apply that update. That way, you're not getting out of sync between what the local admin is seeing for security rules and what's actually expressed in that YAML file. So that's a quick overview of kind of the network protections, process and file protections in NeuVector. There's a great number of capabilities for doing vulnerability management, compliance management, even multi-cluster management. You can create admission control, network rules, process rules, and federate them down into multiple clusters. So if you have global policies like don't allow SCP or SSH into any containers, and you want to push that to every cluster managed by the multi-cluster manager, you can create those here and push them into all of the managed clusters. I guess the last thing I'll just highlight real quickly is a new release of NeuVector and Nexus Container that came out today, 4.4. It's got a little bit better display graphics for some of the screens that we talked about. And it's got something called a vulnerability configuration assessment capability. And that is the ability to upload your deployment YAML that you're going to be used to deploy. So this can be done very early in your pipeline and check it to see if it's going to be allowed in the production environment, or if it's going to be blocked by or hit any admission control rules. So if I upload that, that YAML file that I did in the admission control demo, oh, sorry, I just pushed the wrong button there. And I test that out, I can see that it's going to hit that rule. More than one high severity CVE was fixed. So this is a great way for in the pipeline to continuously audit the deployment YAMLs and flag any that are not going to meet your security policies. Send them back so that when they are attempted to be deployed, they're not going to generate admission control rules in your production environment. And the other major new feature in this release is in the vulnerability management section. You can take a vulnerability that you've evaluated and you can click accept. Therefore, you're accepting that vulnerability and creating an accept profile for that, so it won't show up in your vulnerability reports or in some of the displays in NeuVector. And you can further limit that to this vulnerability is only allowed is accepted in certain images or for deployments in certain namespaces. So it's a great way to avoid the noise of some of the vulnerability scan results that you might see. All right. Hope I wasn't too long-winded there, Jorn.
No, I don't think so. Actually, we've got some questions coming in on the Q&A. I don't know if you have visibility to that screen, but either way, I'm going to read them out loud for the benefit of the audience. And Joao, I hope I'm getting my Portuguese pronunciation correct. He was really curious about it's a very broad question, specifically to NeuVector, about the underlying technologies and concepts. How does it work? And other further clarification. Really wanted to know about the technologies that allow NeuVector to have that observability to the traffic that's live inside of a Kubernetes cluster. I think it was more, I think we wanted to how is the sausage made? What do you mean you can see the entire network? And another question that's tangential is, what's the overhead? Is this, that one comes all the time as well.
I mean, all great questions. They come up all the time. And this applies to both Nexus Container and the underlying NeuVector. So I talked about the enforcer container, which is really doing all that runtime protections. And that's really all part of the core IP of the NeuVector development team. And actually, there's like 7 or 8 patents that were granted in how NeuVector, the technology, is able to kind of direct the traffic It's really like a bump in the wire. So think of it as like a bump in the wire layer 7 firewall. We're not terminating connections. So we don't have that overhead of trying to terminate connections and then reinitiate them like a proxy or something like that. We're not using other technologies like eBPF or
IP tables.
net,
That
IP
question was
tables,
coming in.
network
Is this just,
policy.
yeah,
Yeah,
is
any
this
of
just
those.
IP tables? No.
Yeah, I mean, mainly because this has to be a multi-protocol, super fast, extensible type of security technology with things like you saw, like packet captures and downloaded PCAP files, very clear logging and reporting of this source, this destination, this end IP was attempted at this point in time. You need all that for forensics, and none of the open source technologies really are designed to give you any of that. And then the overhead question is, so I mentioned two modes. I didn't really explain them too much. Monitor mode is where you can run NeuVector in an alert mode only. So for the firewall protection of it, we are kind of like a network tap. We're passively sitting, observing the traffic. So we're not getting in the flow. So there's no performance impact on the application of that. And the same is true of process and file violations, where we'll just alert, but we'll allow those activities to take place. In the protect mode, that's where you saw the blocking take place. And that's where you can choose that for critical applications. So you don't have to have your entire cluster in a protect mode. You can just choose which deployments are in a protect mode. For those deployments, all the network traffic in or out of those pods is going to go through the NeuVector firewall. And of course, for that, we take some memory and CPU to be able to look at those, inspect the packets, hold the connection to determine if it's going to hit a rule or if there's an allow rule, and then be able to drop and block it if we need to drop or block it. So of course, the answer is it depends. It depends on how many CPUs and memory you have in your infrastructure, the network traffic, the types of connections. But in general, we've tested NeuVector in a very small environment with like 4 CPUs and 8 gig of memory and a shared CPU, running the Enforcer as a shared CPU, and measured multi-gigabits of throughputs that the Enforcer can handle. The good thing is it's just a Kubernetes pod. So you can assign one or more CPU cores if you have the need in your environment to process a ton of network traffic through NeuVector. And you can also grant the NeuVector pod more memory if it needs it.
Helpful. Thanks, Glenn. There's 2 more questions in the queue. I'm going to throw them in there in a different order. I wanted to warn Paul, I think there's one after this one that might be more towards you, but Kevin, Glenn, and Paul can fight over that question that's coming up. Before that question, Siva asks, does it support microsegmentation? And that one's for you, Glenn.
Yeah, we use the term microsegmentation all the time. And it seems to be a very, what would I say? It's a techie term, or it's like you're in this group of people that are network security people and they understand microsegmentation. But certainly if you're deploying microservices, then microsegmentation is the capability of NeuVector to segment the traffic on a workload by workload basis for application specific policies. And that's the protocol being used. That's also the source and destinations that we took a look at. Everything has to be very granular down to that microservice. And so that's what we call microsegmentation.
An example might even be, and I know you, in your example, you even showed kind of the difference between it being just open HTTP traffic and HTTPS. Another really good example of microsegmentation is when somebody's using a service mesh overlaid inside of their infrastructure, and you can use, of course, NeuVector and Nexus Container can work hand in hand with that service mesh. There's no butting heads there, but there's a good microsegmentation example that allows you to enforce that service mesh be used by particular services and containers. Because if you actually read the documentation to things like Istio, it says, hey, we can't enforce that you use it. With something like Nexus Container, you can actually enforce that enforcement, so to speak.
Yes, you can enforce encryption. And in addition to that, NeuVector can still inspect the packets, even for pod-to-pod encrypted packets. We have the technology to be able to do that.
Excellent. Next question, and this, Glenn, might be to you, but it might really be to Paul. Like I said, you guys can thumb wrestle over it. A question goes like this: can you please talk in detail if and how CVE findings can be used to block build time integration? And I think that there's some Nexus container talk there, and I know that Paul actually showed a lot of that right in that build. If you want to go back over, can I use a vulnerability to go, whoa, you can't, just stop at the build?
That's correct. And not only can you use the CVE, remember with Nexus Lifecycle, it's a policy engine. So there may be some CVEs or vulnerabilities that aren't a big deal to you, right? And that's why we set up those custom rules. But we have plugins for Jenkins, right? So that we can fail a build if there's a policy that's violated because you found some vulnerability, some CVE. We also have integrations and plugins to Eclipse, IntelliJ, and Visual Studio, so that developers actually can get that vulnerability information as they're actually writing code and using those components. So I think that answers the question, but yes, we are integrated into Jenkins and your CI/CD tooling to where you can take whatever actions those tools allow you to take.
I think the message there is an overarching one. I think everybody in this call would agree with this statement. Code ages poorly, right? You might build an image during build time that passes some checks for you, and it might not get deployed until some days, weeks later. And something may have changed because it's the internet and things change, and you can do those security checks along the way. And even further off, if there's unknown vulnerabilities, 0 days, the protections that Glenn showed you can stop some of those 0-day attacks. And of course, back to Kevin's talk too, making sure that you've hardened that infrastructure before you even start using it. Let's see, other questions coming in, although Jorgens, I think, is tossing us a compliment. He says, I consider myself, quote, the father of the EU NATO cyber defense, and I was completely convinced it's all about taking responsibility with rules, creating standards, and even Kevin threw it out there, making sure that people are involved. There's a culture of DevSecOps, so you know who's responsible for what and watching it through the whole pipeline. Yeah. And he said, you are the spearhead. So that looks like in the QA box, a congratulations to our speakers for doing it the right way. And Jorgen comes in and says, I have specified the intelligent software backbone controlling end user and mutating issues. Okay, I think that's just a bravo coming across inside of the QA. So thank you for that compliment.
Yeah, we still have a few minutes left. So if people have questions, please ask away. Yeah, you can see there's some downloads available there.
And we'll get those all out after this conversation. Let's see, anything more coming in through the Q&A? My window is only so big. I don't see any other things coming in. I do see a lot of compliments and thanks coming in on the chat window. I'd like to throw out some thanks to both Uday and Young for putting together this entire thing, making sure that it works. Thanks to Glenn, to Paul, and to Kevin for bringing some really, really great content. Thank you to the internet for not breaking everybody's live demos. And the biggest thank you goes to everybody who's attending. We know that we're suffering Zoom fatigue. So not only showing up, but spending this time with us is extremely valuable. Again, look for some communications coming back out to you. Hopefully by the end of this week, we'll get those gift cards to you and a link to this entire recording. If you want to review some parts of it or show it to your friends and family over the holidays, that's fantastic, and we appreciate it. And with no further ado, I'm going to declare that we take the rest of the day off, and everybody have a great day and a great holiday season. We'll talk soon.
All right. Thanks, everyone.